let's continue our discussion of graphical displays of univariate data and look specifically now at histograms. Let's jump in with an example, and the example I'm going to use is exam scores. The exam scores are either going to be interval or ratio. It depends on how the score is actually computed. If I'm talking about 0 to 100, that's how many points are actually on the exam, then I'm thinking of that as more of a ratio variable. If I scaled it, pretty much anything that's been scaled, we think of that more as an interval measurement scale. Perhaps there was 231 physical points on the exam, but then it was scaled to a percent and then rounded some way to integer values. So either way, it's going to be either interval or ratio data. And histograms are used for both interval and ratio data, so this will apply no matter how this was actually recorded. Now, notice here on my frequency table, it's the same thing I did earlier, except now I'm making reference to a class rather than a category. Because in qualitative data, nominal and ordinal, each grouping is actually a category. Whereas in interval or ratio, we're not talking about categories, we're talking about classes, class groupings. So that's one minor difference in terminology when I move from qualitative to quantitative data. Now the class is going to be, or consist of a lower bound and an upper bound. And those are commonly referred to as simply class boundaries. Now the upper and lower bound simply tells you what values go into it. That's all it really does. Now, when we talked about ordinal data, when I had my A's, my B's, my C's, and my D's, one of the things I mentioned that we need those gaps. I mean, technically, you should have those gaps in between each of those categories. But here, when I look at this data, the smallest is a 40, and the biggest is 99. It makes sense to me to go by tens, because I know it's on those 0 to 100. My 90 to 100s are my A's, 80 to 90s are B's, so forth. But my F's are going to be below 60. So there's going to be a lot more information there on my F's, because when I finish this up, not only will I see how many people receive an F, but how bad the F was. Was it very close to getting a D? We have people that just barely didn't pass. Or are the people that really had a rough day and their score was really extremely low and no chance of passing? That information will be available there. Now, because of that, I'm going to start off with 40 as being my lower bound. And I'm going to say that's going to be less than or equal to, I'm going to use x as my variable, which I'm going to say is strictly less than 50. So now I know this contains all of my 40s. If the number, or if the value 50 comes up, it will not go in here. Because x, my variable, has to be strictly less than 50. 50 will go into my next category. So 50 less than or equal to x, which is strictly less than 60. Now, see, these bump up against each other. Think of it as some type of continuum. In this first group, 49.999 forever will go in here. But 50, as soon as you hit 50, it jumps to the next. But they're literally infinitely close to each other. Whereas A, B, C, D's, and F's, I don't know, how close is an A to a B? I mean, you put it in order, you put them next to each other in order, but how close really is that? How would you measure closeness? It just doesn't make much sense. But these are truly numerical values, so distances have meaning, so we know what it means to be close with these numerical values. Okay, I'm going to finish up this table now. This would be 60 to 70, 70 to 80, 80 to 90, and 90 to 100. If anybody in here had exactly a score of 100, see, it wouldn't fit in here. I need one more category, 100 to 110. But that's not the case here, so I'm okay. Now, what I want to do is I want to go through and look at these frequencies. The way I'm going to do that is, see the 62? I'm going to mark it off. And where does it go? It goes right here in the 60 to 70 group. 73, that goes here in the 70 to 80 group. 99 goes here to the 90 to 100 group. 93 also goes in this group. 91 goes in that same group. 80 goes in my 80 to 90 group. 87 also goes in the 80 to 90 group. 84 goes into the 80 to 90 group. 85 also goes in that group, as does 86. Oops. I'm going to change that to go like that to mark off 5. That's 86. 96 goes in this group. 91 also goes in that group. 97 goes in that group. 70 goes in the 70 to 80 group. 94, I'm back up here in the 90 to 100 group. 72 goes back in the 70 to 80 group. 44, there's somebody had a rough day, goes in the 40 to 50 group. 79 goes in the 70 to 80 group. 72, 70 to 80 group. 65 in the 70 to 60 group. Okay, now that I have all of those, I'm just going to add them up and see my frequency is 1, 0, 2, 5, 5, and 7. Now, let me grab this paper here because I already cheated and wrote down all the decimal stuff. Relative frequency, if I add all these up, I have 20. So seeing I have the space here, I'm going to say here's my totals. So here's 20 is my total. My relative frequency will be 1 out of 20, which is 5%. 0 out of 20, that one's easy. Don't need a calculator for that one. That's just 0. 2 out of 20, that's going to be 10%. 5 out of 20, it's 25%. Again, 5 out of 20, which hasn't changed. It's still 25%. And 7 out of 20, which is 35%. Now, if I add all these up, this will add up to 100%. If not, then there's a problem. Cumulative frequency. Just as we did earlier, there's nothing changed here. Cumulative is going to be 1, 1, 3, 8, 13, and 20. It's the exact same things we did earlier. There are 20 people that had, 8 people. Right here I'm looking. 8 people had scores of at least 70 or worse, the way I did this, because I started from my 40s. So 8 people scored 70 or below. Probably 3 people, the way I want to look at this, scored below 70, which is a D or below. So the interpretation is the exact same as it was before. Cumulative relative frequency. Well, this is 1 out of 20, which is 5%. This is still 1 out of 20, which is still 5%. Now we're going to move to 3 out of 20, which is 15%. 8 out of 20, which is 40%. 13 out of 20, which is 65%. And last but not least, 20 out of 20, which of course is 1. It's 100%. So there's my table. It's really no different than what we did with the ordinal data, with the exception being of class. In the class, we need to set our class boundaries, and the class switch need to be the same. Okay, so now let's take a look at this and do it by hand, and do a graph by hand. It's going to look awfully similar to what we've done before. It's the same idea. X and Y axes. I'm going to start off with my, 40 to 50 to 60 to 70 to 80 to 90 to 100. See what I mean? I was talking earlier that because this is actually numerical, the 40 to 50, I went right 40 to 50, gap, 50 to 60, gap, 60. It doesn't make any sense. 40 to 50 to 60 to 70, so technically the histogram for interval ratio data, these boxes that we're about to put in there, should be up against each other. Frequency, I'm going to do this as, 2, 4, 6, 8, 10. See, 40 to 50s, I only had one person in there. And I'm going to go ahead and label this, put a 1 on top of it, so that the reader's clear that it's a 1. Because if you look at this, I kind of messed that up. This is so close to 2, just simply by looking at it, it may be tough to tell whether it's a 1 or a 2. So let's make sure the reader has no doubt. There's nobody in this group. There were, in fact, 2 in this group. There were 5 in the 70 to 80 group. So I'm going to label it as a 5. The 80 to 90 was also a 5. And then there were 7 in the 90 to 100 group. And the other thing that would be nice to do is to come back and put in the percentages. That's nice information for a reader. It's all right there in front of them. And if you wanted to, rather than writing it as 0.35, if you want to simply write in 35%, it's a personal choice. Whatever you want to do is fine. Now, what do I need to do to wrap this particular graph up? Well, I need to tell my reader what this is. These are frequencies, so there's no doubt here. This is actually the scores. And what is this about? Well, how about calculus 1? Let's make this, pretend it's from exam 2. So now I have pretty much everything on here that the reader would want. There's a complete graph. So the next thing I want to do is let's step over to the calculator. And I want to enter this data in the calculator and produce the same type of graph using the TI-83 or 84. Now, when we do that, the calculator will give me all these bars. But what it won't do is it won't do all this labeling for us. Now, the calculator may be nice to use to quickly organize, see what the graph's going to look like, and pull the information off. And you see what I mean when I do it here in just a second. But it's a little bit of a trick getting that from your calculator onto your paper for a report. For that, you may want to use Excel if you have access to it, but be careful with Excel, because Excel is not as easy to think to do this type of thing, and it's very easy to mess it up. So unless you know what you're doing with Excel, I'd recommend you stay away from it or learn how to do it. There are all kinds of computer packages that you may have access to, SPSS, Minitab. They all do this sort of a thing. So if you understand how to do it in the calculator, you understand how to do it by hand, then you understand how to do it in most computer packages designed to do this, except for Excel. Excel is a little bit goofy in that respect. All right, let's take a look at the calculator and see what we've got going here. Now, on the calculator, go to Stat, Edit, and L1 is where I put the data. You can see here's a 62, 73, 99. That's just where I put the data in. I did not sort it. I don't have to sort it. The calculator handled all that. I simply put it in the order that I had it written down on the paper. It's no big deal. All right, let's go to the graph. Second, quick, get out of there. Second, and then right above it, you see stat plot above the y equals key. So select it. There's second, stat plot. And I'll recommend that you have all these off. See, mine is set for stat plot 1 on. Stat plot 2 is off. 3 is off, which is really what I want, because I'm going to be working with stat plot 1. If 1 and 3 were on, and there's no data where 3 is pointed to, I'm going to get the error. So probably it's a good idea until you get real familiar with your calculator. Select option 4, which simply turns everything off. Hit enter. It says done. All the plots are off, so you're safe. Go back to stat plot. Select stat plot 1 by pressing the number 1 or the enter key. Notice that it's off. It's blinking here on if I hit enter. On is now selected. Stat plot 1 has been activated. Go down to the type. The type is the type of graph we want to do. Look at these icons. Which one looks like what we're trying to do? There it is. It's histogram. So I'm going to move over to the right. Before I select enter, notice when I had this plot, which is something we'll deal with much later, it wanted X list and Y list. Two different lists here. As soon as I select the histogram, look what happens down here. It changed to X list only, because my data is only on the x-axis. I don't have X and Y data. So histogram has been selected. Now the X list is where's your data. My data is in L1. If you put just in L3, then hit second 3 and make that say L3. Mine's in L1, so if it said anything other than L1, I would select second 1 to make it say L1. Frequency is always going to be 1. If it says anything other than 1, make it a 1. In the TI-83, 84 manual that accompanies your text, there's an example in there of how to, or what type of data you may want to change this. But for now, just plan on leaving it a 1. Most of the time, it'll be a 1. It's very rare that you would change that. Okay, now I'm ready to go. I have everything set. and I want the calculator to produce a graph for me. I'll select zoom, and then the shortcut would be to hit the number 9 key. But before we do that, I want to come down, arrow down to 9 so you can see what it says. 9 says zoom stat. It's going to tell the calculator to zoom in to a statistical plot. It's going to come up with what it thinks is the best looking graph. Hit enter, and there it is. Now notice that does not quite look like the graph that we just did by hand. Well, let's figure out why. If I hit trace, it's going to tell me my min and max. This is my first class. The lower bound is 44. This is saying 44 is less than or equal to x, which is less than 55. See, we went from 40 to 50 because that made more sense to go in groups of 10. But the calculator does not know what this data is. It's got no clue that it's exam scores. It just sees numbers. So I want to fix that. I want to go from 40 to 50, 50 to 60, and so forth. But before I do that, let's just quickly look at this and see what the information is giving. This is from 44 to 55, and n equals 1. There's one observation there. If I move my right arrow key, this is from 55 to 66, and now there's 2 observations there. So we can see the information that the calculator has given us. Let's fix that now. Go to Window. Select the Window key. X min and X max. Well, I started at 40, right? So I'm going to tell the calculator 40. Then go down. X max. I stopped at 100. Remember, 40 to 50, 60, 70, 80, 90 to 100? Okay, X scale. X scale is where the calculator stores your class width. We went by 10s. It's going by 11s. So let's make it 10. Y min and Y max. Well, let's go back to X min and X max. X min says over here on the left, that's where I'm going to start, is at 40. Over here on the right on my screen, I'm going to make that 100. I'm going to scale it so it goes from 40 to 100. The Y min and Y max, it says going down this way on the y-axis, on the bottom of the screen, I'm going to make that negative 1.8, the maximum 7.02. Now, you may or may not need to adjust that. For right now, I'm going to leave it because I know that my highest frequency was a 7. So if I'm up at 7.02, it'll fit. So I'm going to leave it for now. Let's take a look at the graph, and then I'll come back and make some quick adjustments for you. When we look at the graph, do not hit zoom 9. Bad. Don't do that. If you hit zoom 9, the calculator is going to start all over, give the exact same graph you just had. Instead, hit graph. Graph will produce the graph screen with your new settings. That looks like what we had before. Okay, hit the trace key. All right, from 40 to 50, there was one observation. That's what we had. 50 to 60, there's nobody. 60 to 70, there were 2. That's what we had. Let me guess. This is going to be 5 and 5. Yep. 70 to 80, there's 5. 80 to 90, there's 5 more. And then 7. 90 to 100 was 7. Okay, let's go back to window. Let's just suppose we want to change the Y max. We want to make this higher. Maybe you wanted an 8 for some reason. So if you put 8 in there, you need to adjust Y min. If you don't adjust the minimum for Y and you hit trace, there's a good chance that the information that it displays is going to get stomped right on top of your graph. And the formula to use is a negative of the Y max. The negative key is the negative on the bottom, that's in parentheses. The other one is a minus for subtraction. So I'm going to press negative. Y max is 8, so I'm going to put an 8 here. And then divide it by 4. If I put 10 in there for Y max, I'll put negative 10 divided by 4. Now hit graph. And if I hit trace, see all my information fits very nicely in here. And I gave myself a little bit more room up here. Now watch what happens if I put Y max at 8. Let's just make it 10. What the heck? And suppose I wanted Y min at 0. I don't want that to be negative. I want it to be 0. So I hit graph. There it is. There's a nice graph. Same graph we did before. But now look what happens when I hit trace. I mean, it literally stomped right on top of my graph. So I can't see what's going on in here anymore. By taking the maximum, negative 10, dividing it by 4, it's going to take this, the x-axis, and it's going to push it right up to here. So it's going to ensure that you'll always be able to see your graph. So let's do that quickly. Y max is 10, so Y min, I'm going to make negative 10 divided by 4. Hit graph, trace, see it fits nicely. Okay, that's really all you have to do on the calculator end of things. So we just produced a nice little graph. If you do it in your calculator first, that will give you your actual frequencies for each category. I'm sorry, each class. And you can very quickly come back here and draw it by hand. Okay, in the next video, I'm going to take a look at one more type of display, known as a stem and leaf display, and then that'll wrap up the actual displays. We're going to do the graphical displays for this chapter. And only thing left is we want to take a look at the shapes of the distribution, talking about distributional shapes.